Let's say I want to get the mean value or the sum divided by the number of observations of some data. So first let's create some data. So let's do vals less than dash c paren 1 comma 3 comma 5. So the mean in this case is going to be 3. So if I wanted to manually calculate that, I could do the sum of the vals divided by 3, but I could also use the mean function to get this same value. If you like this, please like, comment, and subscribe. Let's say I was interested in calculating the standard deviation and variance from some data. So let's create some data doing vals less than dash c parentheses 1 comma 3 comma 5 close parentheses, enter. So now I can calculate the variance doing var vals, enter. So the variance is 4, and to get the standard deviation, I can just take the square root of the variance of vals, enter, and now it's 2, or I can get it directly doing SD open parentheses vals close parentheses. If you like this, please like, comment, and subscribe. Let's say that you want to perform a t-test on some data that you have. So let's load some data doing data iris, and then we can do a t-test by just doing t.test paren iris $ sepal length. So now we have a one sample t-test where the null is that the mean is equal to 0, and then the alternative is that the mean is not equal to 0. If you like this, please like, comment, and subscribe. Let's say that you want to check if your data is normally distributed. We can use the Shapiro test to do that. So let's look at a toy example by doing data iris. So now that we have the iris data set loaded, we can do Shapiro.test, and then the vector that we're interested in this case is going to be sepal.length. So we can see that our p-value is just around 0.01. So if we were using an alpha level of 0.05, our p-value is less than our alpha. So since we have evidence to reject the null, where our null is that our data is normally distributed, we have evidence that our data is not normally distributed. We can check this visually by also doing a QQ plot, by doing QQ norm, and then doing sepal or iris $sepal.length. So we have this normal QQ plot here, but then we can also add a QQ line by doing QQ line iris $sepal.length. So in this case, it looks like while the center data looks fairly normally distributed, there are some deviations here on the tails, and that's probably what's being captured. And so if we look at the histogram of iris $sepal length, this is another view of the norm of our data, and we can see that it's not quite normally distributed. It's not symmetric. If you like this, please like, comment, and subscribe. Let's say that you want to calculate the correlation between two variables in R. To do that, let's first load some toy data, and then we're going to do core for correlation. So iris $sepal.length, comma, enter iris $sepal.width. So now we can see that this is negatively correlated but close to 0. So if we want to see something that's more positively correlated, we can do sepal length again, but then this time do petal width. And now we have something that is strongly positively correlated. If you like this, please like, comment, and subscribe. Let's say that you want to create a scatter plot. To get started, let's load up some data doing data iris, paren, enter, and now we're going to plot the data. So we're going to do iris $sepal.length, comma, enter, and then another variable. So we'll do iris $sepal.width, close paren, enter. So now we can see that we have a scatter plot with iris sepal length on the x-axis and iris sepal width on the y-axis. If you like this, please like, comment, and subscribe. If you want to build a linear model, we first need some data. So we're going to do data iris. Then we will create our fit. So we'll do my fit less than dash lm petal dot length tilde petal dot width, comma, data equals iris paren, enter. And now we can look at our model, and we can see that we have our coefficients here at the bottom. If you like this, please like, comment, and subscribe. Let's say that you want to get an ANOVA table from a linear model. So to do that, let's look at some toy data doing NPK And then I'm going to get my fit less than dash lm yield tilde p comma data equals npk paren enter. And then I can do ANOVA on my fit, and I can get the analysis of variance table from a linear model. If you like this, please like, comment, and subscribe. Let's say that you want to do the analysis of variance on some data. So first, let's load up some data that's built into R, the MBK dataset, and then I will create my ANOVA analysis by doing AOV, the response, which is yield, and then my treatment versus control variable, which is P. So then the data is MBK, enter. So then I can get a summary of this by doing my fit. Now I have the results from my ANOVA analysis. If you like this, please like, comment, and subscribe.